All right, the final topic that I want to talk about in terms of limits is limits of trig functions. And what we have here are some special limits. There are three special limits that you do need to remember. And the first one is the limit as x approaches 0 of sine x over x is 1. Remember, this only applies when it's a limit and the limit as x approaches 0 of sine x over x is 1. It doesn't mean that sine x over x is always 1, or for any other, as x approaches any other value, this will not necessarily be the case. But whenever x approaches 0, the limit of sine x over x is 1. And the second one is the limit as x approaches 0 of 1 minus cosine x over x. And again, this only applies for the limit as x approaches 0, and this particular value will be 0. And the third one is the limit as tangent of x over x as x approaches 0. The limit as x approaches 0 of tan x over x is also 1 there. So we're going to use these as kind of building blocks to work on the different limit problems in this particular section here. So for the first one, number 67, you can see that that's really sine x over x, but times 1/5. So we bring out the 1/5, and you're going to have limit as x approaches 0 of sine x over x, and that's just 1 over 5. Because the limit as x approaches 0 of sine x over x is 1. All right, the second one. Number 68, as x approaches 0, notice you have the 1 minus cosine x over x. That piece goes to 0, and so 3 times 0 is 0, and that one is going to 0 out. Number 69, you have sine x times 1 minus cosine x over 2x squared. What you'll do is take the 1/2 out. So if we rewrote it as I did over on the right side, the limit as x approaches 0, 1/2 times sine x over x times 1 minus cosine x over x. We'll see the 1/2 is 1/2. The sine x over x limit as x goes to 0 is 1. And the limit of 1 minus cosine x over x is 0. So you have 1/2 times 1 times 0 is 0. Number 70, you have limit as theta goes to 0 of cosine theta times tan theta over theta. So if we split that up like so, you'd have cosine theta over 1 times tan theta over theta. Well, tan, excuse me, tan theta over theta is equal to 1. And so you're left with cosine theta, and as that goes to 0, as theta goes to 0, cosine theta approaches 1. With number 72, again, I'm not going to do the odd ones because the solutions to the odd ones are in the book. This was Chapter 1, Section 3 of Larson, which is the online textbook. So for this one, what we're going to do is split up the tan x times tan x. Then we're going to have, we only have one x, so that'll stay under one of the tan x's. We'll have one under the other. So what we'll do here is we'll get the limit as x approaches 0 of tan x over x, which is 1. And that leaves you with the limit as x approaches 0 of tangent of x. You plug in 0 into tangent of x and you get 0. Okay, and I think that's sufficient for this particular set of problems. Yeah, we'll go on to 74, one more. And so here you're not approaching 0 here, so you have to be careful about that. And secant of phi is really 1 over, that's the Greek letter phi. It's 1 over the cosine of phi. And so when you plug in there, you're going to get pi, and cosine of pi is -1, so it's pi over -1. So this just goes to show you that not every time that you're taking the limit of a trig function are you going to use those special limits that we defined. Sometimes you're just going to do substitution, plug and chug on it. So please be careful for that. If you're not approaching, if x or whatever the variable is not approaching 0, and you're not working with one of the special functions, then try to do it using direct substitution and see what you get from that. So this is a review of limits of trig functions, and this will wrap up the section on limits.